Hello everyone, welcome to Bhavigyan modules and today we are going to discuss the Geodynamics module. I was not uploading the video from long back, but from now I will be uploading the video on the regular basis. So let's begin with the Geodynamics third module, that is plate tectonic and driving mechanism. So this is the first question. Which among the following is correct with respect to Chilean type subduction? Chilean type subduction. There are two types of subduction are there. One is Chilean type and one is Mariana type. So what is this Chilean type? In this, lithosphere your lithosphere is basically thin and hot. So if your lithosphere is very thin and hot and your continent your oceanic plate is going like this. Okay, this is your oceanic plate and this is your continental. So in this case, as this is thin and hot, there is a lot of buoyancy which will occur from the bottom. Okay, so because of this ocean plate will not be able to go much more in depth as in case of Mariana Trench. So this is basically a very big difference between a Chilean type and your Mariana type, that in your Mariana type, if you see your trench, angle of trench is very high. Actually it is greater than 45 degree. Okay, so and here our back arc basin forms, and the back arc basin in case of Chilana type, there is a lot of rifting occur in this zone. So because of this lot of rifting, you can see there is a great earthquake related to Chilean type of volcano. Is it clear? Now let's see the options from here. So the young lithosphere is cold and thick, so this is wrong. As I told, it is thin and hot. And one more very important thing in this your Chilean type volcano is, as I told, that your this lithosphere, it is very thin and your oceanic plate is comparatively cold, as we know that. So here the your oceanic plate will not be able to not be able to go much more down like this. Okay, so it will be here only. So here there is a lot of convergent. So here convergence will be very high as compared to subduction. As in case of Mariana type, the subduction is high. Here in this, subduction is high. So what let's conclude what we have learned is, in case of your Chilean, your lithosphere is thin and hot. Second point, we learned that here convergence is more than subduction. Subduction is less here. Third point, this is a reason of great earthquake due to the rifting in the back arc area. So from here we can clearly see which option should be the correct. So convergence rate is higher than subduction rate. So I have provided the figure here also. You can see from here. See here, your young, thin, hot, buoyant lithosphere is entering, and here your dip of the Vadati-Benioff zone is also very less because of the convergence only. And why it is happening? Because of the buoyancy. Here buoyancy is very high, so your this thing lithosphere is not able to make a high angle of dip. So let's move to the next question now. In the MOR exhibit, so in the mid-oceanic ridges, we have your very less Fourier anomaly because the height is not that much from the sea level, and it will have a negative Boger anomaly. This is very important to understand, that in MOR your Boger correction is positive. Okay, so what is our Boger correction formula? 0.04191 rho h. Okay, so if the Boger correction is very high, we subtract this Boger correction to calculate the Boger anomaly. So if this is very high, so the observed gravity value will become very less in case of this. And why it is happening? Because in case of mid-oceanic ridges, if you see here, the mantle comes very nearby to the surface, and the density of mantle is greater than the density of crust. So this density value will increase. So let's see the options now. Your free air anomaly, small free air anomaly, negative over anomaly. So I have given the description here also for the same. Now next question, as per the figure given below, the offset length between the trench and ridge. So here, this is your mid-oceanic ridges, this is your ridge, any kind of ridge, not mid-oceanic ridge. So this is going in this direction. Now this is up dip and this is down dip. What does this means is, if the figure is like this, okay, so this portion is representing that this is going in the downward direction like this. So this is D, this is U. So if what is the representation of this symbol? It is actually representing this symbol. Okay, so if you observe this, if this plate here, if this plate is continuously going in this direction, and here our ridge is going in this direction, so as per the passage of time, you can clearly see this offset length will increase with the time. Is it clear? So let's move to the next question now. So same previous type of question, in which of the trench system the offset length will be constant with time? So it's a very good question. So अगर मॉड्यूल को एनालाइज करेंगे तो each and every topic पे बहुत डिटेल पे I have focused, so that it will be very very beneficial for the students who are preparing for the any exam related to geology, whether it be GSI, state related geology exam, and very very helpful for the gate. So let's see this question. What is asked? Offset length will be constant in the trench system. So now if you see this first option, this is not a trench system, this is ridge and this is your trench. So this option is wrong. Now this one is your trench system. Now if you see this, I explained you, if I draw the figure here, it will look something like this. Okay, and this one, how it will look? It will look something like this. Is it clear? So if you observe this figure here, your trench length will increase with time, isn't it? If you see the remaining option here, see this option here this is our trench and this is also our trench. Here the plate is going in this direction, here the plate is going in this direction. So if you observe this carefully, just a second, if you observe this carefully in this figure, okay, your trench length will be constant. Why? Because whatever your plate is going in the downward direction, the same plate is coming from this direction also. So let me erase this one once. So this is the correct option for this. Okay, so this D represents your trench is going in this direction like this. Okay, so your trench is going in this direction like this in the right side, and here the downward dip direction is like this. So this will remain constant with the passage of time. Let's move next question. In which of the trench system the offset length will increase with time? So trench system, in this case your offset length will increase. Okay, Now extensional strike slip duplex at the releasing bend result in the formation of. So suppose the boundary is like this, okay, and here is your strike slip fault like this. If you move like this here, so here it will become extensional if you see it, okay. So here in this case of extensional bend, we will get a normal fault, right, plus strike slip. So this normal fault plus strike slip will give a structure which is known as your negative flower structure. Is it clear? And your compression, okay, means if there is a compression plus strike slip fault, this will result in our positive flower structure. And the phenomena which is responsible for this is also known as transpression. And phenomena here is known as transtension. So let's move to the next question from here. So what will be the answer of this one? It will be negative flower structure. So this is the figure I have made. You can see here the extension is there and here your compression is there. So compression will result in the positive flower structure and extension will result in the negative flower structure. Now select all the correct statement related to positive flower structure. So I'll explain it will form due to your reverse faulting and strike slip, and the phenomena responsible for this will be transpression. Next question, select all the correct statement related to negative flower structure. So negative flower structure will be normal fault and trans extension or transtension. This is MCQ type of problem. So most common type of fault observed in OMR mid-oceanic ridges are your normal fault. We know all normal fault is there. We know reverse faulting is not there. Thrust is due to your reverse fault and overthrust is also due to reverse fault. Tear fault is formed when your fault plane dip is 90 degree. So this will be the correct option of this one. So heat flow is observed. Oh, heat flow is observed. Okay, it will be maximum heat flow. I will correct it. Maximum heat flow will observe near your oceanic ridges. Okay. So this was the end of our geodynamics module. I hope some question will be helpful for you. In your upcoming exam, I will regularly upload the video. So thank you so much for watching.